In this video, we learn about the quotient rule for differentiation. Now, the quotient rule is a method for differentiating the quotient of two functions. And what that really means is that it's a method for differentiating one function being divided by another. It states the following. If f of x can be written u of x over v of x, that's one function being divided by another, then the derivative f dash of x is equal to u dash of x times v of x minus u of x times v dash of x, all of which is divided by the square of v of x. Now, make a note of that formula. We're about to work through a couple of examples. Okay, as a first example, let's differentiate f of x equals to sine of x over x squared. Now, the key thing to realize here is that this is the quotient of two functions. Indeed, we have one function being divided by another. So we can go ahead and say that f of x is equal to u of x over v of x, where u of x is equal to sine of x, and v of x is equal to x squared. And their derivatives are u dash of x, which equals to cosine of x, and v dash of x, which is equal to 2x. And so we can use the quotient rule here to state that the derivative of f dash of x, equals to u dash of x times v of x minus u of x times v dash of x. And all of that is over v of x squared. And now, replacing each of these functions, u dash, v, u, and v dash, by their respective expressions, leads us to the following. Cosine of x times x squared minus u of x, which was sine of x, times v dash, which was 2x. All of that over v of x squared. So that's x squared squared. That leads us to x squared times cosine of x minus 2x times sine of x, all of which is over x to the power of 4. And we can go one step further. Indeed, all the terms here have an x. So the highest common factor here is x, and we can simplify. So we can state the final answer as f dash of x equals to x times cosine of x minus 2 sine of x over x cubed. And there we go. We've just differentiated this function using the quotient rule. Let's look at one more example. We're asked to find dy dx given y is equal to 2x squared minus 5 over 3x plus 4. Well, again, the key thing to notice here is that y is equal to one function being divided by another. In other words, we can write y equals to u of x over v of x, where u of x equals to 2x squared minus 5, and v of x equals to 3x plus 4. And so the derivatives of u and v are u dash of x, which equals to 4x, and v dash of x, which is equal to 3. And now, using the quotient rule, we can state that dy dx equals to u dash of x times v of x minus u of x times v dash of x, all of which is over v of x squared. Now, replacing u dash, v, u, and v dash by their expressions leads us to dy dx equals to 4x times v of x, which was 3x plus 4, minus u of x, which was 2x squared minus 5, times v dash, which was 3, all of which is over v of x squared, so that's 3x plus 4 squared. Now, simplifying, or I should say distributing on the numerator, leads us to 4x times 3x, so that's 12x squared, plus 4x times 4, that's 16x, minus 3 times 2x squared, so that's 6x squared, minus 3 times 5, which is 15, all of which is over 3x plus 4 squared. Notice that we rarely distribute the denominator. We tend to leave it as an expression squared, because very frequently we'll be interested in studying the sign of the derivative, and if it's squared, it's positive. It therefore makes our life easier to leave it that way. Simplifying the numerator, we have 12x squared plus 16x minus 6x squared plus 15 over 3x plus 4 squared. Finally, we can state that dy dx is equal to 6x squared plus 16x plus 15 over 3x plus 4 squared. And there we go. That's how we can differentiate using the quotient rule. I hope that helps.